So, introduction to deep learning. This is to answer the question, what is deep learning? If you are here by this time, you have heard the name deep learning many times so far. But if you don't understand what this deep learning is, as a part of this video, you are going to have the basic understanding what deep learning the world is talking about. If I try to define deep learning in theoretical words and sentence, I have write down very simple sentence basically. And this is very brief definitions of deep learning. Deep learning is nothing but deep neural network. A deep neural network is a stack of artificial neural networks logically arranged to solve complex problems through representation learning. Okay. A stack of artificially neural networks logically arranged to solve complex real-life problems through abstract representation learning. Alright, so here are some of the terms which I have used, and you may require some of the descriptions about why those are called these different names, like stack of artificial neurons, abstract representation learning. So I'm trying to go through all these points basically. So before that, let me take you to what is artificial neurons. Alright, so I don't need it now. Don't go away. Alright, so okay, give me a second. Stay here. You might have heard about biological neurons in your body, in basically most of the animal's body. So first of all, I'm going to draw a biological neuron, and then I'm going to draw the artificial neurons. Alright, I'm not a very good kind of artist, so alright, so this is how our biological neurons looks like. This particular section, these are called dendrites. Together they are called dendrons. This is the body of neurons. Okay, and this is called action. Alright, so how it works? It takes input through these dendrons, sends everything to the body, and body process it, create some kind of signal, and then send it through these actions to the next neurons. So you can expect another set of neurons are there which are taking input from here and doing the processing and passing it to neurons, another set of neurons. This is how this information is trained. So we are not interested for this part as of now. Alright, so as a part of the implementation of artificial neurons, the late 80s or 90s early, some of the scientists they implemented similar framework in computer science. Those are called artificial neurons. How they look like? Okay, so I will not take too much space here. These are inputs. Alright, so these are basically inputs, and it is they're collecting inputs here. These are something called weights, different weights and biases. So they're doing a linear multiplications with some of the trained weights and biases with the inputs they're taking, and they're creating net inputs. Then they're passing those net inputs to some of the activation functions, and the activation functions are finally producing the output signal. Alright, so this whole concept came from here. Similar to these dendrons, they're collecting inputs here, they're passing it to the body with some multiplications. So basically from here till here, they're doing all these calculations, they're doing multiplications with weights and biases. They're sending it to the net input calculations. Basically, they are doing a linear sum of all these multiplied inputs, and these activation functions, these are called, for this initial implementation, this is called unit step function. The another name of this very initial implementation of neural network was Perceptron. Right. So these two pictures are clear, I believe. So we don't need it as of now. So we are done with this. So we're trying to mathematically implement this content in the form of kind of metric multiplications in the final output. Alright. So we're done with the biological neurons now. This is our reference. Alright, so these things are input. Let's term them as x1, x2, x3. In the next box are, this is weights and biases. Okay, so initially let's term them at W1, W2, W3. This is the linear multiplications of these contents. So the output of this set is x1, W1, x2, W2, x3, W3. This is called net input. So this is nothing but x1, W1 plus x2, W2 plus x3, W3. In other term, this is called Z. Alright, let's not call it Z. Keep it as it is. Okay. Now this is called activation function. For Perceptron, this is called unit step function. Okay. So how it works, suppose this is unit step function. I'm coming here, okay? Alright, so let's take it as z, and this theta z, this is unit step function. How it works, if the sum linear combinations of these weight and input multiplications are greater than a particular threshold, let's take the threshold as theta. If the value of z is greater than this theta, then the output of these unit step function is 1. If the value is less than theta, the output value of these unit step function is -1. Alright, so how it looks, greater than equal to theta, or z less than equal to theta. Should not be equal to anymore, we have already taken equal to here. Alright, I'm trying to explain it once again. This z is basically the multiplications of input and corresponding weights. So in metric term we can write it something like z equal to the same equation, sum of x and w. Alright, so basically we can term it as this is weights and this is input metric, okay? This x contains input of x1, x2, x3. Alright. So in W contains W1, W2, W3. Alright. So if we simplify these equations, this theta, if we take it to the left side, we'll get one equation called theta z minus theta, unit step function of z minus theta greater than equal to 0 and unit step function z minus theta less than equal to 0. If this particular thing happens, then we'll get basically this output term, let's term it as y. Okay? We're getting y equal to 1, y equal to 0. Sorry, y equal to -1. Alright? Now, so to simplify these whole equations, they introduced one more variable which is not part of the initial inputs, but they call it as bias. So what they do, they introduce another, let me write down in a different box, okay? Okay, it's too much right there. They introduce one new variable as a part of input, that is called x0, and that is equal to 1. Okay? That is being multiplied with corresponding ways, that is called theta. Okay? Equivalent to theta. So they term it as W0. So now we are coming up. Go to some different place. Alright, so this multiplications of x0 and W0 is also being included in net input function. Right, so for reference, let's make it x1 and W1 here. These W0 is called the bias. Okay, these are weights, these are biased. Alright, so the final output is, in this case, the added value to this input metric is x0, let's expand it, and W0. Okay, these two are newly added. Okay, so if we write it down in a graphical manner, so to see how it will behave. So I think I have wasted too much space here. Alright, so this is kind of our XTW, and this is our theta Z. Alright, so so let me write down before that, after inclusion of these biases and kind of these new inputs, unit inputs, so the final equation will be now this Z will be kind of plus x0 and W0 as well. Okay, so the final thing is theta Z greater than equal to 0, then y equal to 1. If it is less than 0, then y equal to -1. Okay. Alright, so this is kind of, this x-axis is WT linear multiplications, and this is sum of linear multiplications basically, and this is the unit step function. Alright, so if the value of this whole thing, okay, this Z is less than 0, so this will go like this, and suppose this is -1, and when it is 0, it will jump from -1 to +1. Alright, +1. Alright, so if it is less than 0, if it is less than 0, then it is -1. If it is greater than 0, then it is +1. Right, we need to write this plus sign here, by default it's plus, okay? If the value of xW less than 0, then the unit step function output is -1. If it is greater than 0, then the unit step function output is +1. Alright, so this is how this particular neuron is being triggered. This is the very basic implementations of unit step function or initial neural network that is termed as perceptrons. So later you will see several advanced implementations of neural networks which contains different kind of concept for this. In the place of these unit step functions, they have different calculations for these equations. For your reference, I am using the term later. I will explain those like sigmoid function, okay, and Rayleigh function and tangent functions. Okay, they have different purposes. All right, so they're using kind of latest and maybe some of the state-of-the-art calculations to produce the final trigger value for those neurons. Alright, so I hope this section is clear. If it is not, then you can write down some comments. I will definitely individually clarify how it is working. Okay, so this is the term which I was explaining, that is stacked artificially neurons. Alright, so this is one artificial neurons. Okay, similar to this, we will have logically arranged several thousands of neurons to create a deep network, very deep network. So let me draw the sketch for those network a little bit. Okay, so I'm just removing all of them. Alright. Bear with me for some time.